Yep, and you're good to go. You can feel free to share. Let's get started.
Yes, let me share my screen first of all. So hello everyone again. Welcome to our third session of Chapter 5. And today we are going to host the session with our guest speaker, with Tyson Kunovsky. He is the co-founder and CEO of AutoCloud. Basically, AutoCloud is an enabler to gather and standardize the multi-cloud and multi-environment data and provides the variety of methods to interact with it. So today's topic is the GraphQL API for AWS. And this session is hosted by GoApp. GoApp is the open source accelerator. Let me to move on the today's agenda quickly. So after the introduction part, we will move on to the presentation part, and later we will have Q&A and wrap up. So as I mentioned, this session is the third session of Chapter 5, and today I'm going to host this session. So it's my first time. I'm doing currently my MBA at Korean Advanced Institute of Science and Technology. I'm joining from Seoul, South Korea, but originally I'm from Azerbaijan. I love reading books, traveling, and challenging myself. It's one of the challenges because maybe in this room I am the one with least tech knowledge because my background is finance. So I hope I will learn today a lot from you guys. And code of conduct. So this webinar is for learning, benefiting, and contributing. This is not for marketing or selling or competing. So, and we value the equality. So if you don't mind, Tyson, we can move on to the presentation part right now.
Awesome. Thank you so much for that introduction. Everybody, my name is Tyson Kunovsky. I'm the CEO of AutoCloud, and I'm going to share my screen and we can kick off the presentation on CloudGraph, which is the GraphQL API for all of your cloud data. So before we get started, a little bit of information about me. Here I am. If you'd like to email me after the talk, my email address is tyson@autocloud.dev. You can find me on GitHub here or on LinkedIn over here. My background is basically software engineering, mobile development, front-end, back-end, DevOps. I've spent a little bit of time doing everything. And I'm really excited to talk with you all today about a new paradigm for accessing data from multiple cloud providers at once. And before we get into that, I'd love to spend just a couple minutes talking about the product that we have created called AutoCloud, which is essentially a SaaS platform that is free for most developers, depending on your utilization, that lets folks get a deep understanding of their multi-cloud or multi-environment footprints that they have. So with AutoCloud, you can do some really interesting things visually. So you can do things like get entire pictures of your infrastructure, understand security, compliance, cost, insight visualizations. We have CloudGraph built into the platform. You can do drift and infra-diff reporting. And there's some pretty powerful, interesting, compelling features. So before I dive into the talk will take about 20-25 minutes to do. I'll spend a few minutes talking about AutoCloud, which again is free for anybody to use. You can go sign up right now. So here's our website, autocloud.dev. And how the platform works is we hook up to your AWS accounts, your Azure subscriptions, and your GCP projects. And using a read-only permission, I'll give you an AWS example, we're able to pull in all of your data that you have for everything running in your various AWS accounts, GCP projects, and Azure subscriptions. And what we do is we automatically lay out this data for you to very easily access and see. So in this AWS example here, I'm going to scroll in a little bit. This might be a little bit laggy over Zoom, but it's not in real life, I promise you. So for example, this is an AWS account, like I mentioned. we just have a cross-account read-only role that has read-only permissions here. And I can then begin to interact and understand how my system is configured. I can do something like click on a CloudFront distribution over here, view all of its metadata, click to view the connections. So without having to do anything like VPC flow log introspection or any other advanced methods, there's a lot that we can get just from the metadata that allows us to go off and understand how entities are connected. I can then click on this S3 bucket that I see the line to. The S3 bucket will then present its metadata to us for inspection. I can view not only the bucket itself, but I can check out any bucket policies that are attached. Here they are. I can view things like the actual security or compliance vulnerabilities that we found for this S3 bucket and what they are. Maybe I want it to be public, but in all likelihood, I probably don't. So that could be a good thing to fix. Here's just all the information that we have. And you can go and you can inspect not just, global level constructs like DNS and CDN, but regional level constructs like S3, like we just took a look at. And then even things like Lambda functions, you're able to go and understand exactly how they're configured. You can see their metadata. You can see everything that you'd ever want to know about them. You're able to view things like VPC related data. You can view things about clusters, EKS clusters. You can even do things like understand what application load balancers you have. And again, if there's any connections, in this case, I believe that this load balancer is sending traffic to EC2 instances inside of an EKS cluster with that are in these target groups. You can view that there, and it's very easy to intuit. We can do things like understand security group membership. So I'll click on, how about this Postgres one? That would be a good example. We'll check out this Postgres security group over here. I can see this Postgres security group. So simply by clicking members over here, I'm able to see that it applies to this database over here. So think of this as just a really robust, quick, and easy way to view all of the data that you have in AWS as an architecture diagram. And the reason that we do stuff like this is to then layer on insights on top of them. So I can show you, hey, from a CIS 1.2 perspective with sections 1, 2, 3, and 4, across all of my where are the potential failures? What are the things that I need to maybe shore up from a SecOps perspective here? I can either view those in a list here, where I can see all of my flagged EBS volumes, and for each volume, what the problems are. Looks like they're not encrypted, or I can click and view, hey, here's a load balancer. This is the one that we checked out earlier. Here's a load balancer, specific related security flags and things of that nature. We allow you to also go and inspect all of your IAM data. So you can view all of your IAM groups and roles and policies and users and all of that fun stuff here. Check out users. So here's what that looks like. Again, if there's any security related things from a CIS 1.2 perspective, like lack of active key rotation, you can view those here. But that's essentially the visual component. You can then cull this diagram down, say that you want to go and you want to filter by, say, a tag with a key of environment. So you just want to see everything that has an environment key. You can do that. You can view all of the stuff that has a key of environment. And then this, you can't see, it's pretty small, but it says management over here. So this looks like a management VPC of some kind. We can make a new diagram with management. We can view all that information over here as well. And then lastly, you can search across all of your resources. So if I search for like EKS, for example, I can view an EKS cluster. It'll zoom in, show me the cluster, highlight it for me. I'm good to go. There's all the metadata. So that's AutoCloud at a high level. We also, because we take different snapshots and points in time, whenever you want to take a snapshot, you can go and we can do very comprehensive drift detection. Here's another example. So say that I have three EC2 instances that were created over here. I'm able to see what those are. If I went and I say deleted 5 EBS volumes, I can show you what the volumes deleted are. And it looks like in this case, the volumes that were deleted had lack of encryption, so they were not encrypted. Because we deleted these volumes, this has been remediated. So you're able to see and understand that. And then you're also able to understand things like changes. So from a change set perspective, it looks like we have different instances in an auto scaling group. Maybe you want to understand what's changed with an IAM role. It looks like for this role, it didn't have any tags. Now it does. Maybe for subnets, you have guessing allocated or unallocated IP addresses. Yep, so IPv4 addresses have changed from 238 to 2008. So 30 of those IP addresses were allocated. So like I mentioned, AutoCloud is free. There are no credit cards required. You can have up to 2,500 assets under management for AWS, Azure, and GCP. I won't get into the more advanced features for this talk, such as the GraphQL API access, because we're about to talk about that for 20 minutes, but we have those capabilities built into AutoCloud as well. So if anybody is curious or wants to know more, feel free to go to autocloud.dev. You can sign up for free. It's easy to get started. If you'd like a demo, we can do that as well. Alrighty, so let's jump over now to the interesting part of the conversation, which is the talk about the GraphQL API for everything. So I have this talk prepared, and what I'll do during this talk is I'll get into the driving principles behind why CloudGraph and why we need a tool like this. And I'll focus mostly on AWS for this conversation, but the same ideas apply to Azure and GCP. And for the record, by the way, big shout out to our CPO, Evelyn, for this PowerPoint presentation. It looked terrible up until about 30 minutes ago when she made it look really nice. So thank you for doing that. And with that, let's get started. So I'm going to make this full screen here. Let's let it load. All right, cool. So AWS has done a wonderful job of building the solutions that let engineers like you and I create the systems to power our increasingly interconnected world. And over the last 15 years or so, products like EC2, S3, RDS, Lambda, etc., have fundamentally changed how we think about computing, storage, and databasing. And with the proliferation of Kubernetes and serverless in the last 5 years or so, AWS services have become increasingly abstract on top of racks of physical servers. To end users like you and me, everything on AWS is just an API. So we don't really need to know how Lambda functions or EKS work under the hood to be able to use them for building applications. And with little documentation or API or console access and a tutorial, pretty much anybody can create anything they need. And these abstractions have led to massive improvements in the overall convenience and breadth of AWS offerings. So you think back to how we did this back in the day, what was once a painstaking, time-consuming, and error-prone process of provisioning new servers, databases, or file systems can now be done in seconds with just the click of a button or the deployment of some Terraform code, for example. And since everything is just an API abstraction, when AWS is ready to release a new product, they simply need to expose a new API to us. I'm, of course, simplifying slightly, but you get the idea. And anybody familiar with AWS knows that APIs on AWS, and for all the providers for that matter, are almost always split into modular namespaces that contain hundreds, if not thousands, of separate API methods for sometimes single resources. So for example, think about EC2, right? One of the most fundamental units on AWS. The EC2 service itself contains 500 different API methods, over 500 actually, and new ones are added every now and then, which is nuts. And then you think of any company building anything substantial on AWS. Well, they're likely using many, many different services. And while this is a master of data center architecture, a masterpiece, the choice of hundreds of services and configuration options puts the burden of knowledge on how to properly use these services squarely on us as engineers. And as a result, we find ourselves having to constantly stay up to date and learn all about all the new service offerings and changes. And this really takes a significant amount of time and mental energy to do. It's quite overwhelming. And as developers, it can be difficult, time-consuming, and frustrating to use the AWS CLI or some AWS SDK to make like 5 different API calls to say, describe an ECS cluster, its services, its task definitions, its tasks, its container definitions. I mean, there's so much to do. And I often find myself lost in documentation and having to use a dozen different API methods to get answers to questions like, well, what exactly is running in this VPC? And I'm not really sure how I feel about the fact that AWS can feel so overwhelming quickly, even to seasoned cloud architects. And while AWS is fantastic at building the actual services that power our businesses, not a lot of headway has really been made into simplifying the day-to-day UX of querying these hundreds of services in the same manner. You think of new solutions like the Cloud Control API, well, they've attempted to create a standardized interface for querying many different types of AWS resources. But unfortunately for the Cloud Control API, its usage is really limited and users still need to know how to correctly query their data. So you need to know how to actually format the requests for data and get the specific data, which means more time spent reading documentation and understanding how services work and are related to one another. And while the data modularity of AWS's APIs is a great logical organization system and makes total sense, it ends up being a burden on end users in terms of cognitive overhead and learning curve. And I don't know about you, but for me, having to remember how hundreds of constantly changing services work and are connected leads to a caffeine addiction and lots of time wasted playing detective. And this brings me to the point, which is, wouldn't it be great if we as DevOps and cloud engineers could have a simpler way to get our data out of AWS, one that reflected our need to easily query any data about any service and any account without having to spend hours on docs or Stack Overflow? And about a year ago, my team and I got to thinking about what such a solution would look like and how we could build a single universal interface that would work across all our AWS accounts. And for that matter, GCP projects, Azure subscriptions, Kubernetes clusters as well. When we thought about how such an optimal solution would function, we came up with three important but not currently supported capabilities. So the first is the idea that data should include built-in relationships between related services. So for example, you take a look at the pseudocode. When you query an EC2 instance, you should be able to easily understand information about its EBS volumes, the auto-scaling groups, or group to which it belongs, target groups, its subnet, the VPC it's running in, etc. These connections between resources oftentimes tell a story of how a component is used as part of a larger system. And it can be very useful in solving all manner of day-to-day operational issues. The second idea is that data should be co-located with insights. So when you do, say, an AWS EC2 describe instances, it would be incredibly useful to also see information about billing, security, compliance, CloudWatch, etc. And when you think about it, the most fundamental unit of organization for any AWS service is the resource itself. For example, any data that you would ever want to know about EC2, cost, compliance, utilization, whatever, it belongs to an EC2 instance. So why not associate the resource with its full insight and data? And if we treat the resource as the primary owner of the data and begin to supplement that resource with additional data, we can vastly improve the cloud insight retrieval process. The third and final capability is that there should be a single open source standardized API and query interface that allows developers to query any kind of AWS data, no matter the service. This is basically what the Cloud Control API has attempted to do, but this API should extend across AWS accounts and even across cloud providers like Azure, GCP, Kubernetes, Oracle Cloud, DigitalOcean, and the others. This would allow for a single unified data source. And just imagine how useful it would be to not have to switch profiles or log in and out of different AWS accounts or cloud accounts to query your data. So with these three concepts in mind, my team and I created CloudGraph, the free open source GraphQL API that co-locates all of your insights with data. We currently support AWS, Azure, and GCP with Kubernetes and Terraform support coming very soon. And I should mention, shameless plug, but we also are willing to pay $1,000 to anybody who can help us bootstrap a new provider with just a few basic services. If you have some spare time and you're interested in helping us out to add providers like DigitalOcean or Oracle Cloud or AliCloud or Tencent Cloud or the others, here's my email address, tyson@autocloud.dev. Drop me a line. I'm happy to help you get started. And we just think it's really important that for FOSS software, you get actually paid to contribute. So what a time to be alive. You get paid for your contributions. All right, back to the talk. So by using the 3 guiding principles of connections, data co-location / supplementation, and multi-environment access, engineers can use CloudGraph to query all their AWS accounts from a single place. And this really significantly simplifies how you're going to be more productive and how you can get your data out of different environments. And let's take a look at 3 different scenarios, one for each of the points I made, where it's currently very difficult to get answers using the AWS CLI, but simple to do right now today with CloudGraph. And for the sake of this talk, I won't get into the technical details of how CloudGraph works under the hood, just because we can do that a little bit later. But feel free to check out, if you're curious, our GitHub repo for CloudGraph to learn more about CloudGraph and the very powerful graph database that backs it. All right, so scenario number 1, what assets are running in a VPC? So today, if you were going to go and query all the things that were running in a VPC, there'd be dozens, if not hundreds of API calls that you would need to make manually. This makes asset inventory incredibly painful and incredibly time consuming. And say that you only knew the name of a VPC, but you didn't know the ARN or the ID. Well, to start, you'd probably need to do something like run AWS EC2 describe VPCs to obtain a list of all of the VPCs to just find the one that you wanted. And now that you know the VPC ID, you need to start querying all the things that could potentially be running inside of a VPC. You might start running queries like AWS EC2 describe instances, and then for each instance, AWS EC2 describe volumes. And then you might also query security groups. So something like AWS EC2 describe security groups. We want network ACLs, the NACLs, AWS EC2 describe network ACLs, the route tables, AWS EC2 describe route tables, and so on and so forth. And for brevity's sake, I'm really simplifying here. There's a ton more calls you need to make. And good luck with all the additional other calls on top of those calls you need to make to understand the relationships that are not explicit. So at this point, you're probably 20 minutes in, you've been Googling, you've been reading documentation, you've been running queries, and you probably only have a sliver of the data that you need to solve the question and get an answer to what's running in a VPC. The format of the data returned itself contains few relationships. So you're either holding all of that relationship context in your head, or more likely, you're copying and pasting output to a literal map of resources that you're building for your purposes. And if you're like me, then chances are you don't even know of all the services that could be running in a VPC. There's just so many. So you need to figure out how to figure that out. And at this point, as is true with most software engineering scenarios, when you find yourself banging your head on the wall, you're probably not thinking of solving the problem in the most optimal fashion. So rather than having an asset inventory of what is running in your VPC become this Herculean task, let's take a step back and reconceptualize the approach to solving the problem. And the good news for us is that if we start thinking in terms of a graph in GraphQL, things just become so much easier. And lucky for us, it turns out that GraphQL backed by a graph database is both a beautiful and expressive way to understand relationships between entities. Because every node in a query can know about n many other nodes, we can write effortless queries like this to traverse up and down between relationships at will to figure out what is really running in a VPC. And here's the example for how to get your info out of a VPC. And I've skipped the full example because it wouldn't fit on the screen here. It's very large. So feel free for those who are curious to check out our documentation, docs.cloudgraph.dev. You can find it there. But as you can see, using CloudGraph, it makes it incredibly simple to effortlessly join across relationships. So user can query a VPC, any ALBs that are in the VPC. You can understand EC2 instances targeted by ALBs. You can even do something like we're showing here, where you can query the VPC, the ALB in the VPC, and then go back to the VPC. So it's pretty powerful and pretty expressive. And it's also important to note here that because we're using GraphQL to do this, everything is type safe. This means that if you use one of the built-in query tools that CloudGraph ships with, like Altair or GraphQL Playground, all of your queries will not only be auto-completed as you type them, but there's also automatically generated documentation like we see here. So no more mistakes about formatting queries or anything like that. And not only will you be able to see all the possible things you could query that could be related to a VPC or part of its metadata, but before you even send the query, it'll let you know if the query is a valid query. So you're not wasting an HTTP request to make a query only for it to fail. So type safety for the win. All right, let's look at scenario number 2. Say that I want to understand how an EC2 instance is configured. Okay, this is obvious. Okay, this is a slightly contrived question, but if I wanted to know how an EC2 instance was configured, I could probably just simply run AWS EC2 describe instances and then find the instance that I'm looking for. And perhaps the raw EC2 metadata that's returned would be good enough for what I'm looking to do. But things get tricky when we start talking about needing additional data and insights related to security, compliance, billing, utilization, etc. All of those additional insights require additional CLI queries or API queries. And you're likely going to have to Google the documentation for how to do that and then write those queries by hand. And for billing, this would mean probably you're going to make a query to the Cost Explorer API. For compliance or security, this might mean queries to AWS config. Note that you still have to set up config and probably security hub in the first place. For utilization, you're likely going to be using the AWS CloudWatch get metric data query for CloudWatch. As we've seen with relationships between resources, there's just a tremendous difficulty associating with the gathered insights and supplementary data together. And this suggests that this might not be the optimal way that we want to query our data. And while I understand the importance of AWS itself having data modularity, I'd go so far as to say that currently we conceptualize insight data access backwards, similar to how we used to believe the sun revolved around the earth. Well, it's the opposite. While there's no arguing that EC2 resource metadata can at times be less important than, say, EC2 security insights, insights really revolve around a specific resource or resource configuration and not vice versa. So in the case of, say, I don't know, potential secrets in EC2 instance user data, it's the offending EC2 instance and its user data configuration that's the source from which the potential security issue originates. And accordingly, from a hierarchical perspective, it makes sense to use the EC2 instance as the container, no pun intended, for all the insights that relate to it. And if we use this paradigm, anytime you access your EC2 instance data, there's a wealth of information co-located that you get for free, along with the metadata that's just waiting to be discovered. And this is information that you don't need to do anything like configure config or security hub or the billing API to get. You get it. And because CloudGraph is FOSS software, it's free open source software, this information that we're showing here in this EC2 example could potentially be extended and supplemented with any relevant data you have, including third-party tools or proprietary internal data specific to your company. And in this example, with a single GraphQL query, we have the metadata over here, we have the billing data, we have CloudWatch utilization data, we even have CIS findings. All of these categories of insight data live on the resource themselves with this paradigm. In my mind, this is just so much simpler than manually looking up how to query all of the different AWS services listed above to return EC2 insight data. And remember, just as was the case with relationships in a VPC, thanks to the type-safe nature of GraphQL, every AWS service in CloudGraph has automatically generated documentation and auto-completion when it comes to writing queries. So this means that you always know everything you can access for a given resource, including what metadata attributes and supplemental data are available. And if you just want to query the insights directly too, you're like, hey, I just want to get back the security insights, that's not a problem. Using CloudGraph, you can always query the CIS compliance/security findings for all of your AWS accounts like this on the left-hand side of the screen. And then on the right-hand side of the screen, say that you just want to write a custom query to go find out all of the EBS volumes that are unencrypted, or the public S3 buckets, or the internet-facing load balancers. It's very easy as well to do that. For insight categories like billing, you can write a query like the one on the left-hand side of your screen here to go get back all of your billing data for all of your AWS accounts like this. Notice how much easier this is than using the Cost Explorer API. Everything is sliced and diced so many ways with different breakdowns that might be helpful for what you need to do. This isn't quite available yet, aside from an AWS EC2, but we're working on adding individual daily costs to all of the different resource metadata. So you can say, hey, give me all of my Azure VMs and give me their daily costs. Same thing for GCP, same thing for AWS. All right, let's talk about scenario number 3. Say that I wanted to understand the age-old question of how does staging differ from production? And I won't get into the configuration and setup details of CloudGraph in this talk, but feel free to either read more about setting up CloudGraph for multiple accounts in our documentation or ask me after, we can talk about it. For many organizations, it's important to have a staging environment that closely mirrors production to allow for everything from better sales demos to full QA regression tests. And whatever the need, if you're trying to compare two environments today, chances are you're going to not only be writing a lot of queries to compare the required resources, but you're also going to have to change AWS credentials before you run your queries against your different accounts. Whether you're doing this via AWS SSO or manually changing the profiles or entering different roles or keys or via some other mechanism entirely, the fact remains that it's just annoying to essentially have to log in and out of different accounts to query your data. And in my mind, this annoyance increases linearly with the number of accounts you have, exponentially for me, is amplified even further by the fact that most of us have at least some resources running in GCP or Azure or elsewhere. And there's, of course, the logical and obvious necessity for AWS, Azure, and GCP to have accounts, subscriptions, and projects in the first place, so users have, well, a different place to store different resource data owned by different people. But when multiple accounts are owned by the same company that are part of, say, an OU that has a shared function like shared networking, it can just make a lot of sense to query multiple accounts at once. Rather than making you log in and out of all of your accounts, CloudGraph supports as many AWS accounts as you can throw it in, allowing you to avoid the headache of switching environments and running the same queries repeatedly. Taking that a step further, say that you have, I don't know, 5 AWS accounts, an Azure sub, a GCP project, and a Kubernetes cluster, right? And you want to get your resource information from those places. With CloudGraph, here's what that query would look like. This is for VMs specifically. On the left-hand side of the screen, have for the CSPs and Kubernetes, how you would query that information. And on the right-hand side of the screen, this is how you would do a specific environment. So I have 10 different Azure subscriptions, 5 AWS projects, 2 GCP or AWS accounts, 2 GCP projects. You can simply specify the sub ID or the account ID, the project ID or the cluster ID that you want, and you can get back the data. It's pretty powerful. And as a bonus, here's how you could do something like, hey, for every VPC in account 12345 that has a tag of environment production, get back the data in that account. And of course, I'm not showing a lot of details in this query. There's a lot more that you probably want to put in here, but you get the idea for sake of brevity. And if you wanted to say just query everything in all of your AWS accounts instead of AWS account 12345, then all you would need to do is remove this filter on line 8 here, and it would give you everything that you need to do. And as with the previous 2 scenarios, what was once a painful process for obtaining multi-account and even multi-cloud data, it now just requires a few lines of query code when you're using CloudGraph. So I guess to wrap up, I want to talk a little bit about the vision of CloudGraph. I think it's really interesting to think about what the future for multi-account and multi-environment cloud data queries holds. If we shift our thinking away from the current paradigm of API and data modularity to one where we can query any data about any service on any cloud, our lives as DevOps engineers become so much easier. We spend less time looking at documentation, holding burdensome context in our head, and we're having to, not as constantly stay up to date with all the new changes that are occurring. So just as Lambda made it really easy for us engineers to run code without worrying about managing the servers that are underlying them, we think at AutoCloud that the DevOps and cloud ecosystem is long overdue for a powerful API query abstraction like CloudGraph. After all, why shouldn't we be able to query our cloud resources and solve the host of compliance, asset inventory, and billing issues that we face every day in a saner fashion, rather. So I guess in closing, feel free to check out CloudGraph if you'd like to simplify your AWS, Azure, and GCP data access needs. And please let me know what you think. I'd love to know your feedback. My team and I, a couple of whom are on this webinar here, are committed to building the open source GraphQL API for everything related to cloud, and we're just getting started. So if you'd like more information about the project, please check out our site, which is just cloudgraph.dev. our docs.cloudgraph.dev, and here's our link to the GitHub right over here. Once again, CloudGraph is completely free open source software. We'd love your help with contributions or at least feedback on the project. And that's the end of the structured part of this talk. I'm happy to turn it over for questions on CloudGraph or AutoCloud that anybody has. Thank you so much, everybody, for taking the time to listen to me as I talk about what I think the future of cloud data access is going to be like.
Thank you, Tyson, for a very informative presentation. So we can move on to the Q&A session, I think. Who wants to ask a question can unmute. Please unmute yourself and ask questions directly. Thank you.
I think I can get started with some intro questions while the folks thinking about it going over. So first of all, thanks so much, Tyson. Really, as a DevOps engineer, it was really one of the exciting products and the problem we are solving. But I still have the question. I'm probably once I try more, we'll have more. So let's start it because you mainly mentioned also integration with cloud and with Kubernetes, but there are also some other tooling, let's say Vault and some other great open source projects that are widely used, and they have their own SaaS version. And not sure if some of them are, they have any GraphQL support and so on. So do you have any plans, any challenges you see that making it to that stage?
Yeah, it's a great question. So I think at a high level, the question is, when you're building the GraphQL API for everything, what are some of the challenges and ways that you can conceptualize integrating things like Vault or Console or Nomad or whatever you happen to be using? So the good news for us is that using the paradigm that we've developed of every data source that we have as in the graph as just a type that we can create, as long as we have a way to authenticate, and as long as the tool in question has an API that is self-describing. So for example, if we're talking about Kubernetes, we just need to be able to understand what the cluster is and information about the pods and the nodes and the namespaces, right? As long as we can query a tool to get back that information, all we need to do is figure out how to authenticate with that and then pull in the namespace or the information. And one of the really interesting things that's possible, this is a little bit of a future state, is hooking together all the different providers and tools so that, what would be an example? Say that you're running Snowflake, right? And you're running Snowflake on AWS. It's pretty easy for us to let you go from a query where you're querying an EC2 instance and maybe Snowflake is running in that EC2 instance to Snowflake now. So joining across providers and tools, that's kind of what the future looks like there. I think the biggest hurdle when we think of building an open source community and building a tool that does this is getting to critical provider coverage. Terraform, or rather HashiCorp, has done a wonderful job of doing this with their provider ecosystem. You go look at Terraform today, and you look at all the different providers that they have. There's a ton that are maintained by HashiCorp. There's a ton that are community open source. I think that even today, using CloudGraph over something like the AWS API has a number of advantages. And in the future, as we begin to integrate other tools, security-focused tools, billing-focused tools, they all become little pieces of data that we can connect your system to give you a holistic picture of your cloud integration and your cloud understanding for what's going on. And we view it as our duty to provide you with sensible defaults as part of this. So for example, say that you don't currently have a cloud security posture management tool and you don't want to pay for one because they're expensive. Well, what we're doing is we're building the base level checks. So for example, the CIS 1.2 checks for AWS, and those are included for free every time that you run a scan. We're doing the same for billing. We're doing the same for drift detection. So over time, we want to play nice with the tools that the ecosystem has at large, but we also want to build the open source foundation for anybody to be able to build their own tools internally. Maybe you're not looking to pay, I'm not going to call it any specific companies, but any security companies, $500,000 a year. Well, you can do it for free with CloudGraph. You got a weekend, you can build it yourself. So I think to answer your question, Sako, the challenges come down to just the number of possible integration points that we need to have and making sure that we can integrate those in a timely fashion to add value.
Amazing. And you were mentioning about the compliance, maybe a bit breakdown of that, because in compliance you have so many standards and so many pieces like infrastructure, application, data piece, and each one still going down more. So do you, what do you think from that? For you think you will be able to cover a lot, or what's approach you are taking to cover most industry use cases? And so will it be also for small to medium businesses, they're fully in cloud, so will it make them fully compliant, let's say, having in place, or it won't be still enough, you need some other tooling around together work?
We want to make it be so that you don't have to have other tooling in place. I'm going to share my screen again and just show you, I have a GraphQL Playground running locally here. Let me make it a little bit bigger just because this could be hard to see. So here we are. This is just CloudGraph. This is basically what you get when you download CloudGraph. And today, right now, what you can do is you can download CloudGraph. You'll need to install the CloudGraph policy pack for AWS. We haven't added documentation on how to do that just yet because it's in beta, but if you're curious, let me know. And to answer your question, here's a query for just CIS findings. If I run this query, it'll go and it'll get me back all of the information from a CIS 1.2 perspective for everything that has passed and failed. So let's take a look at this over here. The description for this one rule over here is AWS CIS 1.2, ensure MFA is enabled for all IAM users that have a console password. And it looks like we failed. And here's the IAM user that failed it. So taking this approach, ISO, HIPAA, PCI, GDRP, CIS, any sort of check from a compliance perspective that you want to be able to do, we make it very easy for you to go and either write these checks. We don't support them right now ourselves, or if you want, open an issue on GitHub and we'll build it. It's not very challenging for us to build out a new rule or a new set of rules. And our hope one day is to have a completely open source security framework where no matter what you want to check from a compliance perspective, whether that's a very customized thing, say that you're a bank and you want to make sure, I don't know, that you're only using EC2 instances that have certain hardened AMIs. You have a list of what those are acceptable to be, or it's just CIS for Azure or GCP. We want to allow you to very easily add your own rules and your own checks, and then out the box, get a bunch of support for things that you currently would have to pay for. It's 2022. We don't have a good excuse in this day and age to not have good security. When there's bad security, we've all seen the headlines that have been in the news over the last few years. So if we can just make this easy enough to use and make it comprehensive enough and get to the place where anybody can easily secure their cloud account, then it's a win-win for everybody, we think. That's kind of the philosophy behind this. Right up next, we're building out the CIS findings for GCP, the CIS findings for Azure. Beyond that, we'll probably move over. We haven't decided the next benchmark, but if anybody has any suggestions, let us know and we can take that into account.
Anyone else? If not, I will ask one more question. So regarding the service meshes Istio, it's providing some out-of-box also observability and all this. So do you have any integrations or plans in place? And if that's, what's the role gonna be there? Because they have some also tracing and all this stuff adding. So do you think that it can be connected there and get all this data on top of what Kubernetes provides? And in general, also for the service mesh, what do you think? Because there are still Istio and all these players are coming. There is no really clear winner, and it's not widely adopted by the industry. Do you want to wait a bit and see how it's going, or do you want to start just?
I think the most fascinating thing to me is the thought that we can start on the pure infrastructure level. So like like I said, everything on AWS is just an API abstraction. It's just the computer running somewhere. But if we can start with, say, an EC2 instance, and that EC2 instance is a node in an EKS cluster, so you're running Kubernetes, and you can dive in and explore the internals of Kubernetes, and then dive in further and explore service mesh and understand how connections are happening and what's able to talk to what and where everything is. You create this amazing tool where you can start at the infrastructure level, go to Kubernetes, go to, say, even the application or the process level, and have that all integrated as part of the same graph. And all we need to do to integrate something into our graph is we either, in the case of Kubernetes, we need to know about the host and just like the VM that it's running on. So I see a really big opportunity in the next year, a couple of years, to integrate service mesh into a tool like CloudGraph and allow you to have that complete observability. And you brought up things like tracing, right? You think of like eBPF or like OpenTelemetry or like some of like the standards that are like pretty popular today. Well, all of those different categories of data that we get from things like OpenTelemetry are just supplemental data points that we can put in our graph. And a graph using GraphQL specifically is very powerful because when you think about the hierarchical nature of these things, you start off with a top level construct. And then if you query something on that, that means that if there's a piece of data available, let's use VPC in a subnet, right? If I have a VPC, and then if I query a subnet and I get back a subnet as part of that VPC query, I know that that subnet is part of that VPC, or at least that VPC can talk to that subnet. So they're connected in some way. All the telemetry data and other interesting data that we can get can be used to help supplement that paradigm and allow us to add more connections and more relationships between entities, such that one day we can have this very, very comprehensive graph, and we can use it for things like identity and access management, allowing you to understand, maybe you're starting off with like an IAM role or like an IAM user, and then querying, what can this talk to over here? What can this talk to? Now I'm on an EC2 instance. Well, can this EC2 instance talk to this thing over here? And allowing you to have that in a graph representation where along each way, you can get back the security information, the telemetry information, utilization information, the billing information, right? That becomes a really powerful tool. So we're working immediately to add coverage for the various CSPs, OCI, for example, DigitalOcean, AutoCloud, Tencent Cloud. When that's done, we're going to take a deeper look into OpenTelemetry, into service mesh, and see what those integrations could look like. In the meantime, if anybody has any spare time, they're interested in adding that and those capabilities, we'll pay to do it.
Yeah, that was one of the interesting, not that usual thing I found, and maybe you can a bit more elaborate on that. There is, I saw $1,000 for building provider. So maybe you can a bit provide some info there. I know there is a nice guide, and so why you came with this approach, which is again in open source, it's usually people do it for just fun or experience.
Oh man, you go on like r/open source, and there's some pretty heated debates there. I won't get too much into the debates right now, but our personal philosophy at AutoCloud is that, what would be a good example? You look at a tool that's super widely used, right? In fact, I won't give a specific example, but any widely used tool that isn't backed by like a Facebook or some like FANG company, behind that tool, there are people that are usually contributing and usually spending their free time that they could be doing other stuff or doing other work for, to contribute because they like it and because they're nice people. But I think in 2022, it's important to not only recognize the contributions from other people and say, hey, thank you, but it's also important when companies have the ability to do so to compensate people for their time in a fair fashion. It doesn't need to be crazy. It doesn't need to be a lot, but I think it's a nice gesture. So do we need necessarily other open source contributors at this stage right now to build out new providers? No, it'd be nice, but it's not super critical in our early stage. But I want to set the foundation moving forward and the expectation that if you're contributing to open source and you're spending hours, days, even weeks sometimes doing that, that you can get a reward for your hard work beyond just, a shout out in a pull request, something of that nature. So we at AutoCloud make sure that we compensate and allow people to be compensated for the initial bootstrap providers. I mentioned Oracle Cloud, I mentioned AutoCloud, Tencent Cloud, DigitalOcean. There's several others in that guide. So if anybody is curious and wants to contribute, don't be shy. It's not scary. It's actually a really interesting it's not super hard. You'll learn a lot of things about graph databases. You don't need to be an expert by any means. Feel free to drop me a note, Tyson@autocloud.dev, and we can figure out how to get you started.
Nice. And I think that would be also follow-up. Folks can start with contributing, and then do you look it as a good thing when you go and look for hiring, and that also helps them in a way that what are the things you usually also
Yeah.
cultural fit? And I know you guys amazing team of engineers, small but solid, so maybe you can highlight a few of them.
Oh, for sure. So previous to starting AutoCloud, I was the head of technology at a company called Inspire 11 here in Chicago, which is a management consultancy. And it was my job to hire people and put in place the engineering practice and culture for how we conceptualize to work as engineers. That meant our paradigms for what we did with various cloud providers. It meant how we ran our software delivery, SDLC. It meant various other aspects as well. And I think that the takeaways that I took there are that it's really important to have empathy. And when we're onboarding new engineers, we do kind of our onboarding presentation. The biggest thing that we look for with other people is empathy. Are you able to empathize with other people? Are you able to empathize with the open source community and the need for solving a problem like AutoCloud and CloudGraph are solving? So from a culture perspective, we have a wonderful team. Shout out to Hernan and Enrique who are here. Everybody on the team is a pretty senior engineer. It's really wonderful. We made that choice to hire mostly senior folks for our initial seed round because we have a lot to build. And like most companies, we want to move fast. So from an engineering culture perspective, I would say that we are hardworking, that there's a lot of really interesting architecture problems that when we bring empathy to the problem, we're able to help understand a good solution that would be beneficial to the market at large. And we also get to use some pretty cool technologies. It's not every day that you're going off and using a GraphQL database that actually is a graph database behind the scenes to go and get your data out. I can't tell you how many CRUD apps I've built over my career. I'm sure a lot of people on this call have been building CRUD apps, and that's basically what they're doing in the day-to-day. But we're working on some really interesting problems as well, aside from just CRUD apps, like CLI tools and graph databases, and a lot of interesting work with dynamic Terraform generation, things of that nature. So I think that, fundamentally, it comes down to when we're doing hiring, looking for people that are interested in the open source community, interested in giving back and having empathy for other engineers, and that want to work on something cool. And I think that those are, the most important points there.
Awesome. So anyone else having questions? Because I can keep asking because it's my field, but if you guys have, feel free to join me.
I might ask a question, but I don't know if it is in context or out of context. I also joined a little late, so I don't know if it's already covered. My question, hello.
Yeah, go for it. We hear you.
My question is about GraphQL itself. So I am a developer. I don't know much about like cloud or DevOps side of it. I have learned about GraphQL itself, and I know it has some advantages over the traditional REST APIs or something. But my question is, why would anyone favor GraphQL over other alternatives like Grpc, for example? As far as I know, Grpc is very performant, and from my perspective, I know that GraphQL has some downsides in performance wise.
It's a good question. So I mentioned during the talk that I wouldn't get into like how things worked under the hood, but let's talk about that for a little bit. So one of the things that we've done, one of the architecture and design decisions that we've made is to abstract that problem away and to use a solution called dgraph, which is they're another startup company. They raised a Series A, and they're a company that specializes in building out the infrastructure behind how to build internet scale GraphQL databases. For those that are interested, you can find them at dgraph.io. And basically what they do is they take care of all the caching. They have done a lot of work on performance. They've done a lot of work on data aggregation. And we're simply able to use their database and build a layer on top of it that takes all the data from the various cloud providers and puts data in it. And in that way, even with large data sets, I'm talking like 50,000 nodes, so like 50,000 EC2 instances, for example, we're seeing, 100 millisecond query times, less than that often, for very, very complex queries that are joined across many, many different resources. So the folks at dgraph have done a wonderful job of optimizing, figuring out how to make that happen. And when we think of just why GraphQL overall, why not REST? Why not another standard? Why not something like, the things that we've been talking about? I think the biggest decision there from a design perspective is that using GraphQL, we're able to get a lot of benefit from a relationship perspective. And when you think about it, there's a lot of other tools out there that do asset inventory. Some of them use SQL, for example, to do this. The problem with those tools and the problem with what they're doing is that SQL doesn't work very well at large enterprise scale when you have to join across many, many, many different tables in order to get data. You have to know not only the primary and foreign keys and what the relationships are, but you're going to see a lot of latency in your queries. We're talking tens of seconds potentially for complex like joins across many resources, and you have to get a lot of data. With dgraph, that's all been optimized and kind of figured out under the hood, such that you can write a single query, get back your data really fast, and it's really hard to break and make slow. So I guess that's the big reason. Then philosophically, as opposed to like, why not just use a RESTful API or something for this? Well, from our perspective, one of the great benefits of using GraphQL is that we can make a single API endpoint, and all you have to do is throw queries at it, and it can give you back the data that you need. We can abstract away the maintenance on the back end, right? There's not a lot of stuff that you have to worry about on the front end. If we're using tools like GraphQL Playground and Altair, you have built-in documentation, type safety, auto-completion as you're typing. There's a lot of really wonderful benefit that makes it very, very easy to use. And because the cloud providers are so complex themselves, you think about mastering AWS, let alone GCP and Azure and Kubernetes, and then the minor cloud providers, that would take a long, long time. There's people that do it, but it's a lot of time and energy. Doing it in this way makes it so that you don't have to have a ton of expertise to be able to use the tool. And it just kind of works out the box. You can instantly get value from something like CloudGraph. So we really focused on usability with CloudGraph, which is one of the big reasons that we decided for GraphQL as well.
All right. That was a good answer. Thanks for the answer. And also, I forgot to say thanks for the presentation as well.
Of course, anytime.
I see you have Mozilla public license. Was there any specific reason that for the open source? Maybe I think that's one of the things also discussed, using Apache versus MIT versus Mozilla. So maybe you can maybe talk about that and these challenges you saw as open source project. That
Absolutely. So funny enough, this is the one decision that I didn't make. I let the team, given, and there was a little bit of input from, being a startup company, we've raised venture capital. There's a little bit of input from legal on this as well, but we chose MPL to make sure that we had a flexible enough license for anybody to use and do whatever they wanted to with it, where they wouldn't have to worry about, you think of the React scandals from a few years ago when React was going to change their license and, oh, we can't use React, we have to use Vue. We want to avoid situations like that, where you can essentially do anything that you want within reason with CloudGraph and be able to use it in whatever fashion that you wanted. And my directive to the team there was, you guys choose the license, figure out what makes sense, I'll support you. And we ended up with MPL2.
awesome. And probably that could be the last question. So do you have regular bi-weekly or monthly the community meetings where folks can join, ask a question, or more it's handled via opening issue? And how's the engagement with the community?
Yes. So we have a Slack group that you can find on our GitHub page. If you search for CloudGraph, we're pretty responsive. So if you were to join the Slack, you'll see that people are being like, hey, I found this bug. And then an hour later, okay, there's a new fix up. So we try and be very, very responsive. If you have any questions about how to use CloudGraph or AutoCloud, if you have any feature suggestions, if you just like to say hi, feel free to join and we can get you your question answered or get you help on the ticket. We can even help you figure out how to use or deploy CloudGraph to say an AWS EC2 instance if you want to run it within AWS. We have a lot of stuff coming on that front soon for ease of deployment and making sure that you have a demo environment that you can query, things like that. That's coming quite soon. But for now, join our Slack group. If you want, you can also go to autocloud.dev. And if you enter your email, you'll be added to our product update list. I hate product update email lists, so we try not to be spammy. I just, I get so many so we only try and do updates when we have some big, cool new things. For most people on this call that are, even if you're working for, some big company, AutoCloud will be free just because you're probably not going to have more than 2,500 assets in your account. And if you have more than that, I'm happy to give you a discount on the actual product. But those are the two ways. I'd say join Slack and go check out AutoCloud and go from there.
Sounds good. Once again, thank you, Tyson. I will let Elvira take from here.
Yes, thank you, Tyson, for a presentation. So we can finalize today's webinar. So I'm going to share with you the contact information of the Tyson later. So thank you, Tyson, for accepting our invitation and hosting this session with us. Thank you for the participants for joining this webinar. Thank you. Thank you all.
I see Burgun,
Thank you, Tyson. It's a very, very perfect presentation. Thank you very much. Thank you.
Thank you.
All new,
Thank
we are
you.
still learning, and I'm sure we will have later more questions. So, but now you met Tyson, guys. Feel free to reach out after or just join community and ask there. So don't be shy asking questions in public. That's the best way to learn because you get more different views, perspective. So that's strongly engaged. So
awesome. Thank you so much, everybody. It was great. Thanks for letting me give the talk and share a little bit about GraphQL in the cloud.
Awesome. I think Elvira, we had the Tyson page. Maybe you can share that to folks.
Oh yeah, sure.
In case if you wanna connect with Tyson.
Yes.
I've already sent the connection request.
Excellent.
So we are still also in early stage, Tyson, but the recording will be there, and more we grow, more we will refer to the community looking for open source project to contribute. So, sorry. Okay, awesome.
Wonderful. Have a great night, day, whatever time it is for everybody.
Yeah. Thank you, Tyson.
Thank you.
For hosting.
Thank
All right,
you.
cheers.
Thank you.
Bye, everybody.
Thank you.
Bye bye.